This slide shows the simulation providing the transition from one peak power point to another peak power point using P-SPICE circuit simulation. The transition is transit between peak power point voltage 77.7 volt transit to 83.5 volt DC. This is the result of two operating peak power point corresponding to sourcing voltage parameter changing from the 50 volts open circuit voltage of 3 power source to another set of parameters that have 2 power sources remaining their open circuit voltage at 50 volts and the third power source changing its open circuit voltage from 50 volts to 80 volts. Overall, this slide shows the step transition from peak power level of 701 watt to another peak power of 877.9 watt. This slide shows how maximum power tracking controller works. Fundamentally, maximum power tracking processing circuit process two quantities. One quantity is relating to power signal and the other quantity relate to sourcing voltage signal. These two signals are processed in parallel with the same transmission delay, go to their respective low-pass filtering, and extract their AC information or AC signal without including their DC operating points. For example, I-bus, which is the total sourcing current that the C-pole converter outputs provide to the system bus. This I-bus have AC information proportional to the power AC ripple that the total sourcing power is provided. PAC is the AC signal corresponding to the change in power or variation in power that the system transfers to the output. VAC is the AC information that have the same information of AC voltage ripple of the sourcing voltage. These two AC signals convert to discrete voltage to their voltage comparator. As a result, these two discrete voltage appear at the input of exclusive OR gate, provide the information for the exclusive OR gate to produce the processing logic to its output Vx. Voltage at the output of exclusive OR gate Vx when is at around or is DC average around 1/2 of bias power supply or 1/2 VDD will cause the voltage integrator to stop integration. Consequently, at this point, will make the output of the maximum power tracker, which is VSP, going into the steady value or stop increasing or decreasing, become the final value corresponding to the peak power voltage. In general, the sourcing voltage that provides feedback to the MPT processing circuit doesn't need to be the actual sourcing voltage sensed from one of power source. Instead, digital signal is sufficient to provide AC ripple information to process the information of power source voltage ripple. The reason behind this because the sourcing voltage ripple already actively regulate to the digital voltage ripple to the command VSPT that superimpose the AC digital signal on the peak power setpoint candidate VSP. In this manner, the system already actively regulate the sourcing voltage, including its AC ripple, to follow the digital ripple. The digital ripple therefore have the in-phase relationship with the sourcing voltage. Because of the nature of digital ripple already in phase with the sourcing voltage, it's simply more efficient to just send and use this digital signal to process to this bandpass filter. The benefit of this approach is that the corrupted noise generated by switch mode converter will not include in the digital signal, since digital signal is just internally generate signal within MPT processing circuit. Make the MPT processing become more efficient without being corrupted by the switching noise generated by power converter.